Hello, I'm Hayley and I'm the Director of the Mathematics MSc at the Open University.
And I'm TC, and I'm the assessment lead on the MSc.
And we're both tutors on the Maths MSc.
Oh, yes. And we're here to talk to you a little bit about the MSc in Mathematics at the Open University. And our colleague Andy Neat, who is not present today, helped write some of the slides.
Okay, so first of all, we're going to talk a bit about the difference between undergraduate and postgraduate. Undergraduate degrees are usually called bachelor's degrees. They can be bachelors of science or bachelors of art.
And honestly, whether you get a bachelor's of art or bachelor's of science depends on the university.
I think there's also a bachelor's of education if it's
yes,
so,
there's some other ones.
But we're talking about postgraduate, and postgraduate degrees, usually they're either a master's, which is an MSc or an MA, or you can get doctoral degrees, things like PhDs or Doctors of Philosophy.
Yeah, and master's degrees, certainly what we're talking about today, are what known as taught master's degrees, where you basically study courses.
Yes, PhDs are research master's degrees. You do get some, PhDs are research postgraduate degrees. You do get some research master's degrees, but the one at the Open University is a taught master's. So you do courses just like you do at undergraduate level.
Yeah. So for an undergraduate degree, you don't already need to have a degree in order to study it, whereas for postgraduate degrees, you typically do need to have a suitable undergraduate degree or equivalent experience or knowledge in order to get entry onto one of these programs.
Yeah, so it's not a hard and fast rule. If you've worked in a relevant industry, you can sometimes get onto a master's degree because you've got experience that you've gained from some other route than just doing an undergraduate degree.
So there are different types of postgraduate degree. We've already mentioned this. We do taught postgraduate masters, and then there are also ones where you do research, and these are typically PhDs.
So why would you want to do a postgraduate degree?
Well, you might actually be interested in maths.
Yes, mainly people do
For
it
us.
for interest or for career reasons. But you can also do it because you want to specialise. There might be particular areas that you want to study more of.
You might be wanting to broaden your knowledge. Perhaps you've done a maths degree or something maths related and just want to learn a little bit more about some of the topics you looked at.
Yes, or you can branch out into a slightly different field. So with a maths degree, certainly at the Open University, you could register for a financial master's degree.
Yeah, and more about those options in a minute. You might be wanting to learn something new. You might want it to move slightly sideways. Or you might just want to keep studying. Yeah, maybe you just want to learn more about whatever interested you at undergraduate level. Or you might just like a challenge.
So at the Open University, if you've already got a maths undergraduate degree, then you can do some quite general MScs. You can sort of create your own STEM MSc or Open MSc.
You can certainly do the MSc in Mathematics, which we're advertising for you today. As Hayley said just now, you can do the MSc in Finance, and also you can do things like an MSc in Space Science and Technology.
But we're mainly going to talk about the one in maths, because we're both mathematicians. So, on to the Open University MSc in Mathematics.
So we have about 500 or 600 students typically studying any given year across the modules.
So that makes us big. We're probably the largest MSc in mathematics in the UK.
Right, we say that because we haven't gone out and actually checked.
No,
but most mathematics MScs are typically going to have tens of students.
And normally students take between 2 and 6 or more than 6 years to graduate. That's because this is distance education and usually students are studying part-time. So typically you might do 1 or 2 modules a year. Students also finish the MSc and then they come back and do the modules they've missed because they find they really do like studying and want to do different ones.
Okay, so if you're interested in the Mathematics MSc at the Open University, you can apply before you have your final results from your undergraduate degree.
Yeah, make sure you're in at least the third year. It's not worth applying if you've only just started an undergraduate degree.
But because of how deadlines and things work, typically most students, if they're going straight from undergraduate degree to a master's degree, will have to apply before they know the final outcome of their undergraduate degree.
If you go on to the Maths MSc website, there's things like a diagnostic quiz.
And various bits of taster material.
Yeah, and you can download it and sort of see whether or not you like the kind of questions that are being asked at MSc level.
Yeah. Most of our students will start with one of our introductory modules. And we have 2 of those, don't we?
Yeah, there's a pure one and an applied one. At the moment, at the time of recording, you can get a loan to do postgraduate courses in England.
But entry to the Masters is not open. You do need normally a 2-2 in a maths degree or a 2-1 in a maths related undergraduate degree.
But we do consider everybody individually. So if you don't quite fit that...
it's still worth applying.
It's still worth applying. Talk to us and we will consider you.
So how does entry work?
Well, the first thing you should do is have a look at the diagnostic test. That's something that you just download. It's a PDF. It's got some questions. Don't worry if you can't do all of the questions. Certainly if you can't do them all immediately, that's completely normal.
Yeah.
Look at the solutions. Have a go at the question. Think, would I know how to approach this? Have a look at the solutions and see if you can follow that kind of level of maths. Because there are pure modules and applied modules you can specialise in as you go through the MSc. So the diagnostic quiz is divided into sort of some basic questions that cover everything, and then there's some pure questions and applied questions. You don't need to be able to do all of the pure and all of the applied ones.
Right. If you're satisfied that you're going to be able to cope with the mathematics and you're still interested, which we hope you are, click on the Register Now button on the Maths MSc website and register on either MA20, which is our introductory applied module covering the calculus variations, or MA23, our introductory pure module that covers analytic number theory.
You have to register on one of the introductory ones first. So if you want to take 2 modules in your first year and they're not both introductory ones, make sure you click on the introductory one before you try and register on the other one. And you might find you need to ring up and talk to the student support team if you want to do something other than just register on one of them.
Yeah. And then the next step is on our side, which is the university will carry out entry checks, basically to ensure that you're qualified to study the mathematics MSc.
If you're not, you get sent through to the faculty and we'll contact you individually. Probably we'll send you some online questions that you just do at home, sort of in your own time over a few weeks. Although if you apply very close to module start, then obviously you won't have as long to do these questions as if you applied well in advance.
So plan in advance if you can.
Yeah, the earlier the better, really.
Now, assuming you go all through this and sign up and you're on the Mathematics MSc, what can you expect?
We have a personal tutor, just like undergraduate OU students do. So you've got a tutor that you can email and ask questions and get support, and that tutor will mark your TMAs, your tutor marked assignments.
Yep. Most of the modules, but not all of them, will have a set book plus a hard copy of wraparound material telling you which books of the book you need to study or expanding on some of the material in the book.
And importantly, the wraparound material tells you which exercises to do to check your understanding and also includes solutions. Most maths textbooks don't have solutions to the questions in them.
So the value added is we tell you how
yes, the Open University ones do have solutions.
Yeah. Most of the modules have 4 formative TMAs.
And by formative, what that means is that in general, for most of them, the marks you get on the tutor marked assignments don't count towards your final result. And that means that you can ask your tutor for help.
You can talk about the questions.
You can email your tutor saying, I haven't got a clue where to start for question 1. Can you give me some hints and tips?
Yeah.
And your tutor will give you hints. And if you follow the hint and you still can't do it, your tutor will give you more hints.
Yeah, and your grade for most of the modules is determined by a final exam, which usually takes place at the end of May, beginning of June.
Yeah, and at the moment it's a remote exam, so it's a timed remote exam. You do it in your house.
Or wherever you can find some peace and quiet.
And there are also online forums, online tutorials, screencasts and other supplementary material, which is basically background material that we think might be helpful if you're doing a module and have got a few gaps.
Now, a natural question to ask is, well, I've only done undergraduate. Is moving up to postgraduate too big a step for me? And the answer is, in general, no.
It's not a huge jump from sort of typical third year, either pure courses in things like ring theory or metric spaces, or applied courses in something like fluid dynamics that's got a sort of fair amount of calculus in it.
Yeah, or statistical dynamics or something like that.
But in general, if you've done lots of third year statistics only modules, those are less helpful for the maths MSc, because this is an MSc covering pure and applied mathematics, not statistics.
At MSc level, things are going to be less algorithmic. You'll have to think more for yourself. But as Hayley just said, you can discuss the formative TMA questions with your tutor, and your tutor is your sort of like point of support.
And once you've got to the MSc, there's not that much difference between the different modules.
No. The step, if there is a big step between undergraduate to postgraduate, but everybody moving from undergraduate to postgraduate is facing this step, so it's not as though it's impossible. It's just that's where the difference lies. So if you're worried about whether you're ready, do our diagnostic quiz.
Yeah, and read the instructions which explain that you don't have to get every single
No.
answer right,
No,
and you
it's
don't
a rare person who gets them all right, actually.
don't expect to look at a maths question, any maths question actually, and immediately know how to do it. It's completely normal to have to sort of try different techniques. If you're doing the diagnostic quiz, to have to look stuff up. You're going to be a bit rusty if you haven't done any maths recently. And if you're sitting there feeling as if somehow everybody else on your course was better than you and you only got your passing mark by a fluke, then that doesn't mean you're bad at maths. It means you've got imposter syndrome.
Yeah, it means you're like pretty much all of us. And
yeah,
you just...
it's completely normal. Everybody is actually secretly thinking that everybody else is cleverer than them.
So that is not a reason not to do the MSc.
Psychological thing.
Okay, so a little bit about the structure of the qualification. It's 180 credits at postgraduate level and includes a dissertation. So you have 5 sort of standard 30 credit modules along with a 30 credit dissertation.
And 30 credits is about a quarter of a normal undergraduate year's worth of study.
Yeah.
So MScs tend to run for a full year rather than the 9 months that undergraduate ones do. So they are 1 year of postgraduate study is in fact slightly longer than 1 year of undergraduate.
Those of you good at fractions will realise that 9/12 of the year is 3/4, and yet we're saying that you're going to be doing 50% more work in a year. So yeah, it doesn't quite map across, but postgraduates qualifications above a bit more.
This is standard for all postgraduate qualifications.
You don't have to do the whole MSc. There are 2 sort of exit points before that. You can get a postgraduate certificate after you've studied 60 credits at MSc level, and you can get a postgraduate diploma when you've done 120.
And typically people will get these on the way, and then you proceed on to the next one. So you don't have to asking to receive the certificate doesn't mean that you've like lost those modules and have to start again. No. Most people end up with 3 qualifications: a certificate, a diploma, and a master's.
At the time of recording, there are 10 modules available.
There's the introductory, pure, and applied ones.
And then we've got these what we call intermediate modules, which are all much of a muchness in terms of level and difficulty, and it doesn't really matter which order you do them in. And
then at the end, there's the dissertation, which is a bit like a big essay, project-y thing. The reason the introductory ones are called introductory is not because they're necessarily easier, but because those are the best ones to start with. And the tutors on those modules are used to the idea that they will be getting new students, some of whom might be completely new to distance education. So there's a different kind of support available there.
Yeah. And so now what we're going to do is just describe the modules to you a little bit. And somehow when Hayley and I were discussing how to split these, I got given most of the applied modules to talk about.
Yes.
Which and the reason why I'm sounding slightly complaining about this is we're both pure mathematicians.
Yes, Andy Neat is the applied mathematician,
and
but
he
he's
wasn't
not
available.
here, so
So winging a bit. Okay, so what is for calculus variations? Well, it's about using calculus to solve minimization problems, like what's the shortest distance between 2 points when there are obstacles in between, or what's the fastest, what shaped slope should you have to have the fastest speed of descent, time of descent.
now don't worry, you're not supposed to be able to do what we're showing you
No,
pictures of. This
no.
is a random thing from inside the course, not something you should know how
You
to do
shouldn't be able
before
to
you
necessarily
start.
look at this and immediately know what's going on. I mean, looking at this, I'm not entirely sure what's going on, but my guess is that first term inside the integral is something to do with kinetic energy, and V usually stands for potential energy. So it's something
Yeah, I wouldn't
balancing
have
the
known
two.
that, which is why 2C's doing the applied ones.
But as I said, I am a pure mathematician. Anyway, so it's about this is a fascinating topic, and a lot of sort of very applied physics problems have been tackled.
And
through
it's
these
actually
approaches.
quite pure in places. So if you're a pure mathematician, you might end up doing it. Lots of pure mathematicians do.
And now this is another applied module, M821. So this is about nonlinear ordinary differential equations. And one of the issues of nonlinear ordinary differential equations is that you can't solve them exactly analytically. And so what you've a challenge instead is to find approximate solutions or try and gain information about the solutions to these equations by drawing things such as phase portraits, which is what those 4 little diagrams on the left are. And that gives you an idea that the solutions are going to follow the lines. And you can kind of see, looking at this, that there are curves sort of traced out in these diagrams showing solution curves.
Now for the first pure one, analytic number theory. Now, you may be looking at this and thinking, wait a minute, how can this subject even exist? Because analysis is all about curves and continuous things, and number theory is about numbers, which by definition are discrete blobs, because we're usually, when we say number, we
talk
mean
about whole
natural
numbers.
numbers,
Yeah.
whole numbers. However, if you think about something like the sum of the reciprocals of the first n natural numbers,
Sorry.
then you can sort of think about that as a bar chart. Think about each bar being 1 wide, so that first bar is 1 wide and 1 high, and the next bar is 1 wide and a half high, and so on. So the sum of the reciprocals of the first n numbers is, sorry, I'm being distracted by the fact that the screen keeps moving.
Yeah, that was my fault. Sorry.
The sum of the reciprocals of the first n numbers is equal to the area underneath that bar chart. Now, if you look at the bar chart on the right, that's a curve. That's the
Not
graph.
a bar chart.
Yeah, that's not a bar chart. It's a curve. That is a graph of 1 over n, and as
1
we
over
all
x.
Okay, 1 over x, but
I
it
guess.
could be n.
I suppose n if n is a variable. Yeah.
Yes, we can choose our variable to be called what we want. It's a graph, and if we integrate that graph and look at the area underneath, we get log x, ln x, log to the base e. So, and hopefully you can look at those pictures and see that actually the area under the first bar chart is very similar to the area underneath that curve. There's just missing a few triangles and things.
And analytic number theory is kind of like about
we
showing that
look
what how you
at
said is true.
Exactly what how big are those triangles, and how big is the error that we get if we use some sort of curve to approximate something jagged like that bar chart. And analytic number theory 2 carries on with that and uses complex analysis this time and the Riemann zeta function to show that the number of primes less than some large number n is roughly equal to n divided by log n.
It's an amazing result.
Yeah, it really is. And it's really clever the way that they do manage to use analysis to answer these number theoretic questions. It's very different to algebraic number theory, which uses algebra, things like rings and fields, to answer number theoretic questions.
Okay, and then there's M833, Advanced Mathematical Methods, and this is around using a computer algebra package, Maple currently, to gain information and insight about solutions to applied maths problems usually. And these are mostly done by numerical techniques, but occasionally analytical techniques can work as well and you can get exact solutions. but primarily it's about learning how to use computer algebra tools to investigate mathematical problems. And then we come to M835, which I'm talking about because currently I'm deputy chair of this module. And this is a sort of a pure maths course, but it has applications, and so both pure and applied mathematicians take it. And this is about understanding what fractals are and learning about dimension and how you calculate dimensions of some fractal objects.
If you look at some of those pictures, you can see that the things they sort of are very complex, very complicated, the shapes. So it's not obvious how you work out what dimension they are.
No. And even if the shape looks complicated, sometimes it's generated in a particularly simple way. And it's that interplay between the simplicity of the definition and the complexity of the resulting picture that gives the subject its interest.
Next, on to coding theory. This is also pure and applied. And it's not about secret agent kinds of codes, that's cryptography. It's got a tiny bit of cryptography in it, but mainly it's about how we transmit data and correct mistakes in the data. So these pictures are...
when Hayley says mistakes there, you mean mistakes in transmission?
Yeah, mistakes in the transmissions.
Interference from other transmissions, solar radiation.
You can also correct for people literally typing the wrong numbers in.
Yeah.
Although I don't think there's anyone actually on the Hubble telescope typing anything in. And that's what these pictures are. That's the Hubble telescope. And the last one is a picture sent from the telescope. Now, if we simply drew the picture as it arrived, it would look a bit like a sort of spacey version of the one on the left.
Yeah, because we can see the bits of missing data.
Yeah, the data downgrades
things that are a bit wrong
as it comes down. So what you need to try and do is somehow correct for that. So when you're working out how to codify the image, as well as sending whether it needs to be a black or grey or white square, you also send some kind of correction or some kind of extra bit of information that can be used if the data has downgraded. And if we made up, we could get really sure and make it really easy to correct if we had a massively long code word.
We could send
each
each grey scale value, say 100 times in a row.
Yeah, and you'd be thinking, well, they're not going to get it wrong 100 times.
So then we would take the value.
But then there'd be too much data. So coding theory uses linear algebra to optimise the solution to the question of how do we transmit data and enable us to correct for any bits that get left out.
Then there's SM880, Quantum and Statistical Mechanics of Matter. And this is a module from our physics colleagues. And this is interested in problems like statistical mechanics is about, if you want to work out how much energy the particles in a room have, well, they're all moving around all over the place. You could try and model each particle individually.
Well, we could try and work out the
velocity and
kinetic energy of every single particle.
But that proves essentially impossible. So instead, we work with sort of averages and try and work out what was happening with the average particle and what its average energy is. And this turns out to be doable. And this is where the notion of things like temperature comes from.
Yeah, so this module looks at the mathematical techniques for doing things like that. And the S at the beginning, that means it's from our science colleagues.
Yeah, and we haven't said anything about the quantum stuff because neither Hayley nor I know much about quantum mechanics.
I know bits because I came into knot theory, but I don't know what's in. We don't know much about the quantum mechanics in this particular module.
Yeah, so we're keeping silent.
Next, we have Galois theory, which is amazing. It's very algebraic, meaning it's about things like groups and rings and fields. Ages ago, the Greeks were trying to work out whether you could square a circle, meaning can you draw a square with exactly the same area as a circle using only a ruler and a pair of compasses. And the ruler is just a straight edge. And they also wanted to know if you could trisect an arbitrary angle. And they couldn't do this, but they couldn't prove that you couldn't do it until Galois came along, who used algebraic objects like groups and fields to show that you can't do these things. So he used algebra to answer what seems like a very geometric question. But it's a fascinating subject, and it's got a very sad story attached to it because Galois sadly died in a duel when he was about 20. And what's in the top right-hand corner of that screen is some of the maths he wrote whilst he was in jail. Not quite sure why he was in jail. I think it was some kind of revolutionary or something.
Gallerard, being a sort of young man in revolutionary France, was actually very heavily against the monarchy.
So there's lots of nice stories and nice, beautiful mathematics in this module.
And finally, we'll just say a few words about the dissertation in mathematics. So it's the sort of like capstone module of the whole qualification.
You have to do this to get a MSc in mathematics.
And it's an opportunity, it's a sort of independent learning at MSc level. It's a chance not to say go off-piste, because we sort of restrict the range of topics you can write about, but it's kind of freer in the sense that you are writing about what you've learned about those topics.
Yeah, it's a list of topics. It does change a bit, but not that often. You pick one of them. There are pure ones and applied ones, and there's a history topic as well if you want to do the history of maths.
Yeah, it's a good stepping stone if you're planning to go on to further independent study or research, because it gives you a sort of research light experience. It gives you a chance to sort of get a sense of what it's like.
Yeah, you're not on your own. You've got a tutor still, and there are tutorials and things, but you're basically building up to writing a big essay project-y thing.
Yeah. We don't expect you to be doing sort of mathematics research, in the sense that we don't expect you to come up with some like amazing new thing at the end of your dissertation.
You can make the whole thing completely expository, which means that you're just explaining what other people have done. So you don't have to do anything independent to pass or even get a distinction.
It's independent in the sense that you have to look at what other people have done and
doesn't need to be
synthesise
original,
but it doesn't have to be like new mathematics in the sense of doing something no one's ever done
some students do produce new mathematics, so it depends on what you want to do and what area you're in, really.
And I think that's pretty much all we wanted to say.
So if you've got any questions, if you're a current OU student, then ask them in the Postgraduate Cafe on the qualification site, and if not, just contact Postgraduate Inquiries and ask about FO4, which is the code for the Mathematics MSc.
So we hope you found that helpful. Goodbye.
Goodbye.